Now the second part of limiting reactant deals with excess reactant. So let's take a look at the next example. We're given the reaction where 1.25 grams of phosphorus reacts with 1.38 grams of oxygen. And we want to find out which reactant is in excess and by how much. Okay, so that means whenever it says how much, we're usually looking for mass. Okay. So let's use our 5 steps and see if we can solve for this problem. Our balanced chemical equation, we have phosphorus reacting with oxygen to give us P4O10, or tetraphosphorus decaoxide. And we are given the mass of phosphorus as 1.25 grams, mass of oxygen as 1.38 grams, molar mass of phosphorus. If you multiply it by 4, we get 123.78 grams per mole. And the molar mass of O2, we get 32.00 grams per mole. So now what we need to figure out is which of these two will be the excess reactant. Okay. Now we do need a balanced chemical equation. So when we take a look, we've got 4 phosphoruses and 4 phosphoruses, 2 O's and 10 O's. So I'm going to put a 5 in front. So now I've got my balanced chemical equation. Okay. So step 1 is good, step 2 is good. Now let's take our masses and molar masses and convert to moles. So to find the moles of P4, I'm going to take mass over molar mass, which is 1.25 grams divided by 123.78 grams per mole. And this will give me a value of 0.01010 moles. And if we do the same for oxygen, we have 1.38 grams divided by 32.00 grams per mole, and that gives us 0.04312 moles. So now if we take a look at our balanced chemical equation, I've got a factor of 1 for phosphorus, okay, or a coefficient of 1, and I have a coefficient of 5 for oxygen. So my phosphorus doesn't change. But for my oxygen, I get a value of 0.00865. So since our value for O2 is smaller, that makes that the limiting reactant, so P4 must be the excess reactant. So if O2 is limiting the reactant, it's going to be completely used up, so P4 is going to be the one that's going to be least. So our limiting reactant was O2, and our reactant in excess is P4. So now what we want to do is find out how much of P4 is left over, or we want to find out the mass of P4 in excess. Since we know that O2 is a limiting reactant, we're going to figure out how much of the P4 is reacted with the O2. So we'll start off with how much O2 we have, which is 0.043 0.4312 moles. And I'm going to multiply it by the molar ratio. I have 1 mole of P4 for every 5 moles of O2. And that's going to give me a value of 0.008624 moles. Okay. So in order for all of this O2 to react, you need this much P4 to react with it. So now to figure out how much is in excess, we take what we start off with, which we call our original, and we subtract what was reacted. So above, we see that we start off with 0.01010 moles of P4, and we reacted only 0.008624, so then the leftover will be what did not react for P4. So we'll take the 0.01010 moles and subtract the 0.008624, and we get a value of 0.00148 moles. And then we can use our conversion using molar mass to figure out the mass of excess. So it's just moles times molar mass, 0.00148 moles multiplied by 123.78 grams per mole, and that'll give us a final answer of 0.18 grams. So now you do need to make sure that when you are taking a look at moles in excess, okay, that your answer at the end is positive. If you get a negative value, then you've made a calculation error somewhere, or you may be using the limiting reactant rather than the excess reactant.